Hello everyone, welcome to Math Direct. Today's video we are going to be talking about L'Hopital's rule. L'Hopital's rule is good when finding a limit of indeterminate form. So what do I mean by indeterminate form? So if you have to find a limit and you get it 0 over 0 or infinity over infinity, then you need to apply L'Hopital's rule. So L'Hopital's rule says that when limit, let's say limit x a fx gx, you need to differentiate the numerator and differentiate the denominator and plug in x equals to a, x equals to a. So this is how to apply L'Hopital's rule. So you need to differentiate the numerator, differentiate the denominator, and plug in x equals to a. And this rule can apply as well if the denominator g x is not equals to 0. So if this is equals to 0, this rule doesn't count. Or if this is equals to infinity, it doesn't count as well. So this works when finding a limit that is indeterminate, 0 over 0 or infinity over infinity. Then you can apply L'Hopital's rule here. So we can solve example and solve some problems in order to understand how L'Hopital's rule can apply to problems. Let's say we have limit, find a limit when x is equals to 0, sine x over x. Looking at this equation here, looking at this problem, we have x as a denominator here. When you plug in 0, so it's already indeterminate. So we can apply the L'Hopital's rule here. So how can we apply L'Hopital's rule? As I said before, we have to differentiate the numerator and differentiate the denominator, and we plug in x equals to 0, and we can find our answer. We can find the limit of our curve, of our line, whatever that is. So we apply L'Hopital's rule here. So we differentiate the numerator here. The numerator, so we can say d over dx sine x divided by d over dx x. So sine is cosine, is cos x divided by 1. Then we can apply x equals to 0, x equals to 0 here. So cos 0 over, we already differentiated this. We cannot apply x equals 0, so it's already 1 here. So this is 1 over 1 is equals to 1. So cos 0 is 1. And yeah, this is our answer. So our limit here when x approaches 0 is 1. So this is how we can apply L'Hopital's rule. And we can solve, more problems regarding this. Let's say 10x. So we can also apply L'Hopital's rule here, because when we plug in x equals to 0 here, it's not defined. So we have to apply L'Hopital's rule here. So we have to differentiate the numerator, differentiate the denominator, and plug in x equals to 0 to know what is our limit when x approaches 0. Okay, so we differentiate tan x. Tan x is sec square x divided by 1. So what we did here, we differentiated d over dx tan x over d over dx x. That's what we did here, and we got this. Now we have to plug in x equals to 0, but first, looking at this, we have to simplify this equation in order to make it easier for us to work with. So remember our trigonometry, sec x is equals to 1 over cos x, and sec squared x is equals to 1 over cos squared x. So this is equals to that. We have to replace this to this, okay? So 1 over cos squared x over 1. So 1, 1. You know, this is equals to 1 over cos squared x. And replace x equals to 0 here. So x equals to 0, 1 over cos squared 0 is equals to 1. So cos 1. Cos 0 is equals to 1. So 1 over 1 equals to 1. So the answer is 1. So when x approaches 0, what's the limit when x approaches 0? Is equals to 1. Considering this equation here. So we can go on and on in order to solve these kind of problems. Let's say we have exponential x minus exponential minus x over x. So the opposite rule applied to this as well. So when we differentiate the numerator, let's say d over dx, ex minus e minus x divided by d over dx, x. So differentiate ex is exponential x is exponential x. We differentiate exponential minus x is minus exponential minus x divided by 1. And this is equals to exponential x plus, because minus minus is plus, e minus x over 1. So exponential, we put x equals to 0 here, putting in x equals to 0 here, so that will be e is equals is e 0 here plus e minus 0. So exponential 0 is 1, so this is equals to 1 plus 1 is equals to 2. So this is your answer. We are going to be talking about integrals of polynomials. So far, been talking about differentiation, talk about integration as well. Integration of polynomials is like the opposite of differentiation. So so far we know differentiation, on how to differentiate polynomials. Now we have to talk about integration. In calculus, we talk a lot, we use integration a lot in order to solve problems. We solve problems using integration of polynomials, integration of trigonometries. Integration can come in various forms. So we need to understand how to integrate when we see problems arises. So let's say, for instance, we have integration, we have something like this, and ax b, for instance, dx. So in order to integrate this, we need to consider the power here. The power here is b, and to integrate this is axb plus 1 divided by b plus 1 plus c. So this is how we solve integration problems. So whenever we see a problem like this, like a polynomial problem like that, we need to consider the power of that derivative. The derivative is x right here, and we need to plus 1 on top and divide it by whatever we have here. We divide it by that number. So this can be replaced with a number. Let's say, for instance, we have to integrate 2x raised to the power of 2 dx. So in order to integrate this, we 2x 2 plus 1 over 2 plus 1 plus c. So this will be 2 x3 over 3 plus c. So this is the answer. When we differentiate this number, we'll get back what we have. Let's say you want to prove that when you differentiate this answer, we get back this answer. We get back our initial number, 2x raised to the power of 2. So integration, differentiation, we bring the power in the front. So that will be 2 times 3, x raised to the power of 3 minus 1. So this is divided by 3 here, and this will be 6x 2 over 3. So 3 cancels 6 is 2. So this is 2x2. So we have our initial problem when we started. So differentiation of this gives you back the original number, and integration gives you this number here. And integration can come in various forms, can come in, as I said before, can come in trigonometry, and it's a different rules that applies to that. Like when you want to give you sine theta, the theta, in order to integrate this is minus cos theta plus c, and integrate cos theta, the theta is sine theta plus c. So these are the little rules you should understand when solving problems like this. And we are going to dive in solving problems so you understand how we can integrate and tackle problems moving forward. And when they give you something like this, integrate a x minus 1, this is equals to integrating a over x, say dx here, dx, and this, to integrate that, will be a 1 over x dx is equals to integrate to 1 over x is 1. So this will be a 1x. So this is your answer when you try to integrate something like that. When you given integrate dx over square root of x, okay, how can we integrate this? We need to break this down into a more simpler form. So this is actually equals to 1 over x half, or you can say it's equals to x minus 1 over 2. Right? Now we can work with this, and this is dx. So we can integrate this. So integrating, you have to consider power. X minus 1 over 2 plus 1 divided by minus 1 over 2 plus 1. So we have to break this further and get our answer. So x here will be x. You can solve it. Minus, this is 2. This is 1 plus 2. So minus 1 plus 2 divided by minus 1 plus 2 is 1. So this is 1 over 2. This is equals to x 1 over 2 over 1 over 2. And this is equals to 2x minus 2x 1 over 2. Or you can say 2 square root of x. So this is your answer when solving a problem like this. We can solve more problems like this. Let's say we have integration of 1 over s3 dx. So this is equivalent to x minus 3. Okay, dx. So to integrate this, we consider the power. So we do x minus 3 plus 1 divided by minus 3 plus 1. So this is equals to x minus 2 over minus 2. So this can just break it down a little further. 1 over 2 minus 1 over 2 times x minus 2. Definite integrals, you will see a problem that look like this when you see AB fx. In order to find the definite integral of this, you need to integrate what we have fx, and you need to apply the limit of a and b. So this is f b minus fs_b on fx_a. Definite integrals. There's always a limit. There's always the starting limit, the lower limit, and the upper limit. When you apply this rule, that you can actually solve a problem that have a limit, the upper limit and lower limit, and we can integrate that and find our answer. Okay, when you give the problem like this, 9 4 dt over square root of t. So this problem can be solved. This is a definite integral, has a limit, upper limit, lower limit. So we can solve this problem. So this is equals to 1 over square root of t, or you can break it down, say it's equals t minus half. So this is the same as that. So we can integrate this number. So t minus half plus 1 divided by minus half plus 1. So minus half plus 1 is equals to half. So t is 1 over 2 over 1 over 2. And this is equals to 2t half. Now we can apply our limit here for 9. So t 9 half minus 2 4 half. So square root of 9 is 3, so 3 times 2 is 6, minus square root of 4 is 2, 2 times 2 is 4. So this is equals to 2. So this is how to implement definite integrals that have upper limit and lower limit. Thank you so much for watching, and make sure to subscribe to Math Direct. I will see you guys later.